Okay, going to work out the practice test for y'all. I'm not going to go into as much detail as I would with a normal video. I'm going to go through these fairly quickly, but I thought it would help y'all to see my thought process as well as seeing the final answers, which will be posted as a PDF. Alright, so question number 1, I'm looking at this. The inside x squared plus 16 has a derivative that is almost on top, so I'm going to do u sub. Du would be 2x dx. I'm missing the 2, so I'll put a 2 offset with a 1/2. So this is going to turn into the antiderivative. 1/2 2x dx becomes the du, 1 over root u. And what I like to convert the limits of integration. So if x is equal to 0, u is going to be 0 squared plus 16. My lower limit of integration will be 16. If x is 3, u would be 3 squared plus 16, which is 25. So that's kind of just a little thought bubble there. Then I can go into the antiderivative. So this will be 1/2 antiderivative. I'm going to bring that u up to the top as a negative 1/2 du. Integrate that. That would be 2u to the positive 1/2. Don't forget the 1/2 out front. And we'll evaluate this from 16 to 25. This is going to be very nice because 1/2 of 2 cancels. And we are left with the square root of 25 minus the square root of 16, which is 5 minus 4, which I believe is 1. So there's your answer to A. Or answer to number 1, whatever. Here we have a piecewise linear function. This is an integral defined function right here, and whenever I see an integral defined function, I immediately find its derivative because it's so flippin' easy. See, g prime is going to be f of x. You simply plug the x in for the t. Technically, you multiply by the derivative of what you plug in. Now I'm going to finish reading the question. Which of the following is true? Let's see, they asked for g. It's a whole bunch of values of g, so it actually turns out my derivative is unnecessary. But, like, let's look at question A. It asks about g of negative 4. Well, if you remember back to algebra 1, g of negative 4, I simply am going to plug in negative 4. Whoops, that's not what I wanted. I'm going to plug in negative 4 for the x's, right there and right here. So g of negative 4 will be the antiderivative from negative 1 to negative 4 of the function f of t, which is simply an area question, and area is very nice on this problem because these are all just good old squares. So let's see, I'm going to go ahead and start finding the area because I see that my areas go all the way out to 3, which is right here. Let's see, this block is an area of 1, this block is an area of 1/2, 1/2, 1, 1/2, 1/2. Now remember, under the curve means between the curve and the x-axis. So I'm simply going to write out all these areas. Now remember, there are such things as negative areas, and one way you can get negative areas is what's happening with g of negative 4. G of negative 4 means I'm going from negative 1 to negative 4. That's a right to left motion. So going from right to left in itself is a negative area. And so then I will add up the rest of these areas. Another negative area is when you're below the x-axis. So all of these highlighted ones right here are going to be negative because they are below the x-axis. So when I'm computing the area from negative 1 to negative 4, that total area would be negative 1/2 plus, and then I have 1, 1/2, another 1/2 is an area of 2. But since I'm going from right to left, that would create another negative. So what's negative 1/2 plus 2? 3/2. So the actual answer is negative 3/2. G of negative 1 is going to be the area from negative 1 to negative 1. I don't even need to look at the graph of that one because I'm not going anywhere. That area is 0. And those are not the same, so I will count that one out. Okay, so let's go to B. G of negative 3 is going to be the area from negative 1 to negative 3 under f of t, which again is a negative area. I'm going from right to left, so it's negative. And then negative 3 to negative 1, if I look at that area, it's going from here to here. That's an area of 2. so that would be negative 2. And then let's see, g of positive 3 is going to be the area from negative 1 to positive 3. This one's taking a little bit longer than I wanted to. So negative 1 to positive 3, that's going to go from here to here. Now I'm going from left to right. That is positive direction. So this first triangle has an area of 2. The second triangle has an area of negative 2. And so that area is 0. And once I got that, I now have noticed that g of negative 1 and g of 3 are both equal to 0, which actually is what C is saying. So the answer is going to end up being C, because at that point I've found all of my values and C is the correct answer. All right, so there's our area. Just remember, the way you get negative areas are the graph is either below the x-axis or you're finding area from right to left. Okay, number 3, another tricky one. Anytime I see absolute values, I usually will graph. So I'm going to start by ignoring the absolute value, and I know that the graph of e to the negative x looks like this. It's going to crash down, and well, let's move that up some. There, it's going to look something like that. But this is e to the absolute x, and the absolute, negative absolute x, is going to keep your positive x's the same. So all of these will remain unchanged. However, it will reflect those across the y-axis, and that blue graph is e to the negative absolute x. And we are finding the area from negative infinity to infinity, the whole thing. I'm going to take advantage of a property here. This is symmetric with respect to the y-axis. So I'm actually going to find the area from 0 to infinity to get rid of one of those two infinities. And on the right side, the e to the negative absolute x is the same graph as e to the negative x. But that's only half of the area they want. They wanted negative infinity to infinity, so I'll double that. This is an improper integral, so I will now change this to a limit. Limit as k approaches infinity, 0 to k, e to the negative k. Oh, forgot the 2. Negative k dx, that's negative x. That antiderivative is e to the negative x over negative 1. That's one of those memorized ones. Evaluate that from 0 to k. That's the same thing as negative 1 over e to the x. And finally, I can evaluate that. That's negative 1 over e to the k minus a negative 1 over e to the 0. And then remember, we are evaluating this as k approaches infinity. So as k approaches infinity, that would be 2 times 1 over infinity, which is 0. E to the 0 is 1. 2 times 1 is 2. So there's your number 3. Let's see. Oh, geez, words. The efficiency of an automobile engine is given by the continuous function r of c, where r is measured in liters per kilometer. Okay, that's important. R is a rate. So basically, r is a derivative. Yes, yes. C is measured in kilometers. What are the units of this? So we are finding the antiderivative of a rate. The antiderivative of a rate will give you a total amount. And we simply want the units of the answer. So if we do the antiderivative of liters per kilometer, it will get rid of the rate part of it, which is the per kilometer, and it will give you an answer in liters. Now, if that didn't make sense, you could think of it graphically. I have no idea what the graph of R looks like. There it is. So there's my R of C. The units are liters per kilometer, so my y-axis is measured in liters per kilometer. And they tell you that C, the C-axis in this case, is measured in kilometers. Well, if you think about a rectangle, if I were to do, say, Riemann sums, if you think about a rectangle, the base of that rectangle, if you're going to measure base times height, whoops, that's not an H. If you're going to measure base times height, my base is measured in kilometers, some change in kilometers. My height is measured in liters per kilometer. And when you cancel your units, you are left with only liters. So we are finding the area. If you think about area, the units cancel, leaving you with liters. There are a couple of ways you could think about that one. So there's 4. 5, straight up antiderivative. I noticed that my inside, The derivative of that would be 2x dx. I have the x. All I'm missing is the 2. So I'm going to turn this into a u sub. X squared plus 1 is my u. Du is 2x dx. I'm missing the 2. So I'll put a 2. I'll offset it with a 1/2. And this thing would turn into 1/2 antiderivative of square root u du, which is u to the 1/2. Add 1, u to the 3/2, divided by 3/2 is the same as times 2/3. The 2's cancel. Don't forget the plus c, and then we simply plug our u back in, which was x squared plus 1. So x squared plus 1 to the 3/2 divided by 3 plus a c, which looks like c. Yeah. Moving on. Let's see. This one, when I first look at it, it just looks like a normal antiderivative. However, the option of non-existent, the only way the area under a function can be non-existent is if this is an improper integral. So that kind of makes me think about improperness and propertuity here. I don't know, proper, only if improper. And it actually happens that this function does have a vertical asymptote at x equals 8. And we are finding the area from 0 to 8. So 8 is a vertical asymptote. That does create an improper behavior for this one. So to actually work this out to the satisfaction of the Math League of America, we have to turn this into the limit as k approaches 8. That's not an 8. That is. Of the antiderivative from 0 to k of, and I'm going to go ahead and move that radical up to the top, 8 minus x to the 1/3, negative 1/3 dx. I am finding area on the left side of 8, so I'm going to make that 8 from the left, and then we'll work out this antiderivative. I guess we could do u sub to explain this in full detail. U sub, u is going to be 8 minus x. Du would be negative 1 dx, so I'm missing a negative 1. I'll put a negative 1 there. I'll offset it with a negative 1. So that's negative 1. Antiderivative of u to the negative 1/3. Du, which will be u to the 2/3 divided by 2/3, which is times 3/2. There is a negative there, and then we'll plug our u back in. And so that's going to be negative 3/2 times 8 minus x to the 2/3 evaluated from 0 to k, and then we'll plug in our 0 and k. So negative 3/2 times 8 minus k to the 2/3 minus 8 minus 0 to the 2/3. And then finally we evaluate this limit as k is approaching 8. And if k is approaching 8, 8 minus k becomes 0. And this is negative 3/2 times 0 to the 2/3 minus 8 to the 2/3, which is 4, which is going to be positive 6. C. All right, number 7. Antiderivative. This one is just a typical parts problem. It's like your prime example of parts. You could try u sub, but it's not going to work. I'm going to do parts where my u is x. My v prime is going to be sine x. The derivative of u is 1. The antiderivative of sine is negative cosine. Now, if you can do the derivative of u down to 0, you can do this little cheap shortcut trick. As long as you can keep doing antiderivatives, the antiderivative of negative cosine is negative sine. And to finish this up, we will do the positive product of u times v, the negative product of the next two, and your answer is going to be negative x cosine x minus a negative sign, which is plus sine x plus c, which is d. Did I do that right? The derivative. Yeah, that's right. That seems different than what I got yesterday. Okay. Let's see. F is differentiable for all functions. Which of the following must be true? Okay. Number 1 here. If you find this right here. Since we know that my function is differentiable, that means that my function f is continuous. If f is continuous, then the area under the curve, if you have a continuous function, anytime you do a definite integral, you will get a constant answer. And the derivative of any constant would actually equal 0, not the original function f. So 1 is not true. And actually number 3 is the exact same thing, except that does equal 0, so we know 3 is true. So we can eliminate, let's see, if 1 is not true, we can eliminate c and e. And now we have to figure out if 2 is true. And the way I would do 2 is, if you find the antiderivative of f prime of x, that would simply be the original function f of x, right? If it is a definite integral from 3 to x, oh, by the way, that's a t, not an x. T, t, t. If it is a definite integral from 3 to x, then you simply will evaluate that from 3 to x, which would be f of x minus f of 3, which actually is not what we have. We're missing the f of 3, so 2 is not true. 3 is the only one that's true. Let's see. This one's nice. Love these problems. Anytime you have an integral defined function, you find the derivative by plugging the x in for the t. So f prime of x is going to be the square root of x cubed minus 1. Now get in the habit of always multiplying by the derivative of what you plugged in. I plugged in an x, the derivative of that is 1, and then f prime of 2 is going to be the square root of 2 cubed is 8 minus 1 is 7. Yep. Also make sure you are going from constant to variable. It's going from 2 to x. It's not going from x to 2 or anything like that. If the order of the limits is different, then it kind of changes how you work this problem. I'll see, number 10. Hey, what do you know? Here's one where it changes the order. I really prefer the order to be from constant to variable. So what I'm going to do first is change my function f of x. I would rather the constant, square root of pi, even though it's ugly, that is a constant. I would rather the square root of pi be on bottom and the 3x be on top. But if you flip the limits of integration, you make the integral negative. Then to find the derivative, which is all this problem is asking, it's negative. You plug the 3x in for the t. So it's going to be negative cosine of quantity 3x squared. Then you multiply by the derivative of what you plug in. I plugged in 3x, its derivative is 3. That cleans up to negative 3 cosine. 3 squared is 9, x squared is x squared, negative 3 cosine x squared, not x squared. There we go. C. 11. Looks like U sub, because I'll look on the inside, I see an x squared. The derivative of x squared is 2x. I have a 6, so maybe the first thing I'm going to do is pull that 6 out. There are a couple of ways you can do this problem. I'm going to start by pulling out the 6, and then doing my U sub, where U is going to be x squared, du is 2x dx. I'm missing the 2, so I'll put it there. I'll offset it with the 1/2. That would turn into the integral 3, because 6 times half is 3, antiderivative of sine u du. The antiderivative of sine is negative cosine of u du. That's not du, plus c. That'd be 3 times all that. And u is x squared, so that'd be negative 3 cosine x squared plus c, which is c. 12. Let's see, water flows into a tank. Gallons per minute is a rate, so pay attention to units. So this function is a rate. If the tank held 32 gallons at t equals 2, okay, that is an initial condition. What we have here is an initial condition. They didn't give you any names for these functions. I'm going to say A of t is the number of gallons in the tank. I'm just going to define that myself. Now that's the actual amount, that is not the rate, and what they're telling you is that at time 2, the tank held 32 gallons, and the derivative of A is this. They gave us the rate of change, so A prime of t is going to be 6t squared plus 1. We want to know ultimately what is the amount of water, how many gallons at time 1. Anytime you have the rate and an initial condition, you could use this little formula, which I've given you before. A function's value at b is the same thing as, the initial value, f of a, plus the area from a to b under its derivative. Total change, accumulation, fundamental theorem of calculus, you can call that whatever you want. There's a lot of different appropriate names. In this case, my function is a, and my initial condition was 2. So if I want my amount at time 1, I'm going to start with my amount at time 2, and I'm going to add the change from 2 to 1 under that derivative. A of 2 was 32 plus antiderivative from 2 to 1 of 6t squared plus 1 dt, and that's a fairly easy antiderivative, power rule, so we'll knock that out fairly quickly. So that would be 32 plus, just make sure you don't get that 32 wrapped up in the antiderivative. Antiderivative of 6t squared is going to be 2t cubed plus 1, which antiderivative for that is 2t, whatever, from 2 to 1. So 32 plus, plug in the top number first, plug in 1. 2 times 1 plus 1 is 3. Plug in the 2. 2 cubed is 8. Times 2 is 16. Plus another 2 is 18. And we get 32 minus 15, which is 17. D. One of the mistakes I see here, people just get careless and accidentally plug in the 2 first. So, all right. Next one, 4x root x minus 1. I trend towards U-substitution. This is not recognition or power rule. Let's see. I generally will do u to equal the radical inside. Du would simply be dx. Now we run into a slight problem here for just a minute because I have my du is right here, and when I start substituting, I get the antiderivative of the square root of u du, but what I have not done is accounted for this x. So what we could do, we have two options. We could abandon parts, and we could go into, we could abandon u sub and go into parts. However, I'm actually going to continue with u sub because all I need to do is figure out what to do with this x. And if I know that u is equal to x minus 1, I could actually solve that for x and find out that x is equal to u plus 1, which actually can be substituted in for x right there. So I'm going to turn this into the antiderivative. I'm going to pull the 4 out. It's a constant. Antiderivative of u plus 1 times u to the 1/2 du. Aw, crap. I'm looking at my options and it looks like they did u sub. Ah, this is going to make me angry. Maybe not. We'll see. That's the problem with multiple choice. I would distribute the u. Maybe it's going to work out okay. Distribute the u to the 1/2. You add exponents. 1 plus 1/2 is 3/2. 1 times whatever. 1 times anything is the same thing, right? Good old multiplication times 1. Now the antiderivative, I take it back. This is going to work out nice. The antiderivative of u to the 3/2, add 1. 3/2 plus 1 is 5/2. Divide by 5/2. So multiply by 2/5 plus u to the 3/2. 1/2 plus 1 is 3/2. Divide by 3/2 plus a c. And then I'll plug my u back in. So that's going to be 4 times the quantity 2x minus 1 to the 5/2 over 5 plus 2x minus 1 to the 3/2 over 3. And the problem with multiple choice is a lot of times their answers will not resemble yours. I think in here they simply distributed the 4. 8/5 x minus 1 to the 5/2 plus 8/3 x minus 1 to the 3/2. Yeah, the answer is A, and they just distributed the 4 through the options. All right, let's see. 14. that looks an awful lot like arctan. I know the derivative of arctan is 1 over 1 plus x squared. So that's in the back of my mind. The problem is I don't have 1s in the denominator. I have 4 and a 16. So what I'm going to do is I'm actually going to turn the 4 into a 1 by factoring a 4 out of the denominator. So that'll give me 1 plus 4x squared. No, I'm sorry. I would rather have a, I mean, that would work. We could either factor out the 4. I'm actually going to factor out a 16 because I would rather have a 1x squared, because I do know there's a little formula that the antiderivative of 1 over a squared plus x squared is 1 over a inverse tangent x over a. So I know that little property, and that's what I'm going to steer towards. So if I can get a 1x squared, I don't care if there's a number being added to it. So I'm going to factor a 16 out, which would actually give me a 1/4 plus x squared. I could pull that 16 all the way out. 1/4 is the same thing as 1/2 squared plus x squared. And now I actually am in this format where I can use the formula. So that's going to be 1/16 times, and it's 1 over the number being squared, arctangent of x over the number being squared, plus c. 1 over 1/2 is the same as 2. 2 over 16 is 1/8. Arctan x divided by 1/2 is the same thing as 2x plus c, which is c. Good. All right, number 15. Oh, this is going to be my favorite problem on the whole review. Anytime I have a fraction, the very first thing I look for is to see if I can make the top be the derivative of the bottom. And I'm looking at this one. My denominator is 6x plus 12. The derivative of that is 6. If I put a 6 up here and I offset it with the 1/6, my top is the derivative of the bottom. So this answer is going to be 1/6, the natural log of the bottom. Uh-oh. Is that an option? It is not. Okay. I have warned you multiple times that on AP style questions, they love to play with properties of logs, and that is exactly what happened on this one. You have to know how to finagle your natural logs, and on this one, I'm going to have to do a little bit more magic. That's the same thing as 1/6 times the natural log of, geez, I'm trying to figure out how to do this, 6 times x plus 12, right, plus a c. And one of the properties of log states that if you are multiplying inside a log, you can actually split that into addition. So that's the same thing as the natural log of the absolute value of 6, which is just 6, plus the natural log of the absolute value of x plus, that should be a 2, not a 12, x plus 2, right? The 1/6 is still out here, the plus a constant. So now I have 1/6 natural log of 6 plus 1/6 natural log of x plus 2 plus a c. Notice that is not there, still not there. However, I have gotten to a natural log of x plus 2, which I have several of. What happens on this one is 1/6 natural log of 6 is just a constant. And if that is just a constant, then I can simply take that constant and I can roll it into the unknown constant here. And if I have an unknown constant plus a constant, I still have an unknown constant. So the answer ends up being 1/6 natural log x plus 2 plus a constant. That didn't have the plus c. Well, I'll be. How did I forget the plus c on that one option? Okay, typo. There should be a plus c there. The answer is B. Okay. See, 16. This is a U-sub problem where the U-sub has already been chosen. W equals 2x. The thing you have to remember to do is identify the du, or in this case the dw. dw is 2dx. I don't have a 2, so I have to put a 2 in here, and I'll offset it with a 1/2. And if I'm not mistaken on this one, the correct answer is not in the options. I worked this one yesterday, and I seem to remember it not being here. So anyway, when I do my u sub, my du is 2 dx, so it turns into 1/2 the antiderivative of du, oh, this is dw. And f of 2x becomes f of w, but what you have to remember is change the limits of integration. If x is 0, you have to change limits into values of w. If x is 0, w is going to be 2 times 0, which is still going to be 0. However, if x is 2, which is my upper limit of integration, w is going to end up being 4. So the correct answer is supposed to be 1/2 area from 0 to 4, f of w dw. That is not an option. I think I meant for this one to have a 1/2. I don't know. So we'll just say this is option F. The correct answer is 1/2 area from 0 to 4 of f of w dw. There we go. I might change the review and fix the problem. Oh, geez, really? And upload it to my webpage corrected. So if you are looking at yours and the correct answer actually is on your review, that means that between the time I recorded this video and you printed or looked at the review, I changed it on my webpage. So that should be a 4. There, finally I'm right. Okay, 17. I have 4 more and I don't have much time. Let's see if I can knock these out. 17. This is going to be very similar to 14. Because 17 I'm looking at, and I know that there's a property that says that the antiderivative of something squared minus x squared in radicals, that antiderivative is the inverse sine of x over a. So what I'm going to try to do is steer this integral into that, and I really want a 1x squared. So in the denominator, or under that radical, I'm going to factor out a 9, which would leave me with 4/9 minus an x squared dx. The square root of 9 is 3, so I can actually pull that 9 all the way out as a 1/3, which would give me 1/3 antiderivative of 1 over the root of 4/9 is the same thing as 2/3 squared. And now I actually have it into that nice formula. That's 1 over root something squared minus x squared. I can use this formula here. That's going to be the inverse sine of x over 2/3 plus c, and x over 2/3 is the same thing as 3/2 x. Oh, I have 3 more. Can I knock them out real quick? Hopefully. Okay, this problem, we're given a velocity. This is going back to that total change thing. We have a rate of change, and we have a position. We know that at time 0, my position is at 1. So if I want my position at pi, it's going to be my initial position plus the area from 0 to pi under this function, 6 sine of, and I'm going to change that to 1/2 t dt. S of 0 is 1 plus, that's 6. The antiderivative of sine of 1/2 t, the antiderivative of sine is negative cosine. And if you are multiplying by a constant, the antiderivative, you divide by that same constant. And then we'll evaluate that from 0 to pi. So that's 1 plus 6 divided by 1/2 is 12. So I'm going to make that a 12. Too many noises. Too many noises. And then the antiderivative when I evaluate is going to be negative cosine of pi over 2 minus a negative cosine of 0. Why are they making so much noise? So that'd be 1 plus 12 times cosine of pi over 2 is 0. Cosine of 1 is 1. And that would end up being 13, which is E. And I'm going to have to pause this. All right, so let's finish this. Fraction, look, see if the top is a derivative of the bottom. It is not. So I'm going to factor this. This looks like a partial fraction problem. My denominator will factor to x plus 3, x minus 2. That's going to equal a over x plus 3 plus b over x minus 2, multiply the whole thing by the common denominator, x plus 3, x minus 2, which would give you 1 equals a, x minus 2, b, x plus 3, and then I like to zero those out, so if x is equal to 2, that will give me 1 equals a goes away, 5b, a fraction, b equals 1/5. If x is equal to negative 3, then 1 equals negative 5a, the b cancels, and you get a equals negative 1/5. Now that I have partially fractally decomposed the problem, I rewrite the original as the antiderivative of, it was a, so negative 1/5 over a was over x plus 3, plus b, which was positive 1/5 over x minus 2, dx, and I'm going to factor out a 1/5 antiderivative of negative 1 over x plus 3 plus 1 over x minus 2 dx, and both of these fractions, the top is the derivative of the bottom. Be careful with that first one because the top is actually the negative derivative of the bottom, but they are both natural logs. The first one's going to be the negative ln of x plus 3 because it's a negative 1 on top. The second one, top is derivative of the bottom, so ln of x minus 2. And now, just like one of the earlier problems, always look to see if they have played with properties of logs, and I think they have. It looks like we're adding logs, but actually it's subtraction because the first one's negative. That could be combined as the natural log of x minus 2 over x plus 3 plus c, and I bet you that's in there. It looks like e. All right, and the last one on this section, improper integral, change that to a limit. K is going to approach infinity, antiderivative 1 to the infinity of 1 to the k of 1 over k squared. What am I doing here? X squared plus 1. This should be an easy antiderivative because you should recognize that as the inverse tangent of x from 1 to k. So that would be the inverse tangent or the arctangent of k minus the arctangent of 1. And then as you approach infinity, remember we have to do the limit of this thing, infinite limit. I'm going to think about the graph of tangent in order to answer the inverse tangent question. And tangent comes up and does something like this, right, with vertical asymptotes at pi over 2 and negative pi over 2. Do remember that your domain of inverse tangent is always between negative pi over 2 and positive pi over 2. And if I have the arctangent of infinity minus the inverse tangent of 1, tangent equals 1 at pi over 4, so that one's going to be pi over 4. Inverse tangent of infinity means when does tangent approach infinity, and tangent is approaching infinity at pi over 2 as we approach pi over 2. So the inverse tangent of infinity is going to be pi over 2 minus the pi over 4, which is the value of arctangent of 1. Get a common denominator, pi over 2 minus pi over 4 is going to be pi over 2. So our answer is D, and I think that's all of them. Oh, why is that right there? But I've already done that one. Why is number 2 way at the end? I don't know. All right, there we go. So there's the non-calculator multiple choice part.